Okay, so we are going to start off now, lesson 1, by talking about number relations or number relationships. And in order to describe more effectively what I mean, I want to draw your attention to this other screen. So I have two sets of numbers. Each circle represents a set or a group of numbers that I've created. There's no particular reason that I chose these numbers except that they were easy ones. So I could have easily made this first set of numbers like 6, 7, 8, 9, 10 or 10, 20, 30, 40, 50. It doesn't really matter what numbers are in there, and actually they don't have to be in a pattern like counting by tens or counting by twos. They could be totally random. However, for the sake of simplicity, I've chosen 1, 2, 3, 4, 5 in this first set and 2, 4, 6, 8, 10 in the second set. And a number relation or number relationship it just means that the numbers over here on the left are connected in some way to the numbers on the right. So maybe I would draw this line. This is going to show how the numbers are related. Let's say 1 is related to 4. 2 is related to 10. 3 is related to 2. 4 is related to 6, and 5 is related to 8. Now notice I have intentionally been totally random. Maybe you expected that I was going to link the like 1 to 2, 2 to 4, 3 to 6, 4 to 8, like counting in the method that we normally would count in. But I want to draw attention to the fact that random is okay when it comes to number relationships. The most important thing is just that the numbers over here are connected to some number over here on the right. Numbers on the left, or this would be your right. That's my left, so left to right. Are connected in some defined way. I should say that in a specifically defined way. So that's a number relationship. When we have number relationships, we have a starting number or a starting section, which we would call like the input number. So I'll write input. And then we would get out or get an answer, or it would be connected to something that we call the output value. So we have the input set and the output set. What that means is if this number relationship was kind of like a machine, I'd put the 1 in and I'd get the 4 out. I'd put the 2 in and I'd get the 10 out, and so on and so forth. Now, input and output are nice words to describe like the number we start with and the number we end with. But in math, we have more mathy terms than just input and output, and hopefully they are familiar to you. So the input we call the domain. So those are all the numbers in the starting set, and then the output is called the range. So those are the numbers that we're linking to. They're the output. They're the numbers that we get second. So we start with the input or the domain number, and we get the output or the range. So if I'm going to go into the little number machine, I'm going to put 1, 2, 3, 4, or 5 into the number machine, and I'm going to get out 2, 4, 6, 8, or 10. Or I'm going to put the domain numbers in, and I'm going to get the range numbers out. Another way of saying this is to talk about the input as being the independent values, and that the output are the dependent values. And those are valuable terms because they show that the independent, like if you think of what independent means just in regular English, independent means that I can stand alone. I kind of am all set all by myself. I can do this all by myself. So the independent numbers are the starting set. They're the numbers that stand all alone. They're kind of just there to begin with. The dependent set of numbers we don't find out about the dependent numbers until somebody tells us who the independent number is. So let me tell you what I mean by that. The independent number would come along and say, I have a 1. And then the dependent number, the number that depends on 1, according to our little set here, is 4. So here's my independent number just coming along and saying, hello, I am the number 1. And the dependent number says, hello, I'm 4. I'm linked to 1. Anytime 1 comes up, I come up next. Input 1, output 4. Okay, so important vocabulary terms here are input versus output, domain versus range. Those are actually the most important. Let me underline them. They are the most important. Domain and range. And then that also could be described as the independent set of numbers and the dependent set of numbers, which is closely linked to calling it the input and the output. Okay, that's what a number relationship is. Now, sometimes it's a little bit easier to describe these numbers if we put them in something we call a T-chart. So let me show you what I mean by that. T-charts can either go this way or this way. And we usually label them X and Y. Now here's where I know we've talked in class about how much we like the variables X and Y, and it's because they come up in algebra all the time. We're always seeing X and Y, X and Y. And that's because X is the variable that we usually use to describe the domain or the independent variables or the independent numbers. And then the Y we call, we link that to the range or the dependent. So this is the input and this is the output. And I can use this to create any kind of set of numbers. So let's say I say my X or my input set is, I'll do 1, 2, 3, 4, 5 again. It's kind of typical. And then my Y values could be anything. I mean, I could have 3, -3, 10, 4, and 3 again. I mean, we can have any combination of numbers, but I'm describing this as a relationship between two sets of numbers. The top set, so I'm going to put a relation. The top set is the domain or the input, and the bottom set is Y is the output or the range of numbers. That is our second way of describing sets of numbers. Now I'm going to show you a third way. Hopefully these are all familiar, right? They should be. I'm just going through a list of how these all would relate. I could describe relations as two sets, kind of just linking numbers across. I can use a T-chart, or I can use what we call ordered pairs. So I could, instead of writing this as X and Y in two rows or two columns, I could pair them up. I could say 1 goes with 3. Where did I get that? Well, I got that right here. Input 1, output 3. Then I could look at my second pair. Input 2, output -3. So I'll write that as another ordered pair. 2 and -3. And I can continue on. 3, 10, 4, 4, and lastly 5, 3. This is our third way of describing a relation between two sets of numbers. First one was the two circles, second one was the T-chart, third one is the ordered pair. Our fourth one, which I'm not going to diagram out for us right now, would also be a graph. So later on we're going to talk about how then these ordered pairs, we can graph those on like an XY axis, which I know you've looked at before, but we will eventually review that again. Like, how do I take these ordered pairs and graph them out? So in summary, we're talking now, just really quick, we're talking about two sets of numbers. The most important vocabulary word you can remember here is domain and range. It's the independent and the dependent sets of numbers, and they're linked together in a relationship where if I give you an input number, you can then say, this is the output that goes with that input. So now, we'll finish here in this video. In the next one, let's talk about what it takes for a relation between two sets of numbers to be defined as a function. What are the rules necessary for it to be a function?